Okay, so I totally forgot about your questions. So I'm going to make a video just for your questions. All right. So you said, why does it stretch left? And when graphing, how do you know it stretched or shrinks? Okay. So in the 2.5 notes, when I redid them, it became a little clearer for everybody. So if I have, let's take your first one, g of x is equal to 2 square root of x plus 2, okay? So if I have that, what that tells me is this. This right here, because it's x plus 2, actually, you know what, let's do it this way. Number one, I kind of want to make this a little smaller. So g of x is equal to 2 square root of x plus 2, okay? So I want to look at this plus 2 part of it first, okay? So really what it's saying is, what it's saying is g of x is equal to 2 square root of x minus a negative 2, okay? So that is telling me that I'm shifting left 2, okay? So that's what it's telling me. So if you look at this formula here, right? It says g of x is a times f of b times x minus c plus d, right? So what it's saying is, and the reason why I wrote it that way is because some of it affects the x and some of it affects the y, right? So that's why I went into this part here, because the a and the d is outside the f of x, so that's why it affects the y value, while this is inside that parentheses where x usually is, so that's what's going to affect the x value. And we notice that there is that negative sign right there, right? So every time I think about it, I have to write it that way. So now it shows me that negative 2, so I know it's a shift to the left, okay? So when I do the order again, the order of operations is what I have to do. So I got to go inside first, deal with that. So that's going to be the first thing that happens, okay? Then I'm going to look at this 2 here, okay? So if I look at the 2, let's make it blue. Actually, let's make it a thinner blue, all right? So with the blue, what that is doing, and this is going to be number 2 here, what it does is now either it's affecting the y, so it's either going to be a vertical stretch or a vertical shrink, okay? So what I would show here, come on down, so green is the A, purple is D, so everything in purple here is affecting about the D. Everything C is here to the right and blue. The A is green and the B is red. So if you come all the way down, you'll see the green and the red. So this is a vertical stretch or shrink. So if it's a vertical stretch, then A is greater than 1. All right, and if it's between 1 and 0, and this is the absolute value, so meaning don't worry about the negative, let's just look at the positive version, is that greater than 1, right? So even if it says negative 2, the absolute value of negative 2 is still positive 2, so therefore that's still greater than 1, so it's going to be a vertical stretch, right? The negative sign there is only talking about reflection, which is what this is right here, okay? So if A was negative, then it will reflect over the x-axis because the y went from positive y to a negative y, or even a negative y to a positive y. So it had to flip over the x-axis, all right? So that's why everything there. So that's how you would know if it's a vertical stretch or a vertical shrink. Now, if you notice in the purple, I talked about narrower and wider. And the reason I was saying that is because if I had, let's say I had a parabola, so, well, first of all, let me finish this thought here for this problem. The 2 means, so how would I put it this way? Let me erase this part. So the 1 says shift left to left 2. That means I'm going to subtract 2 from the x value. Okay, so that's what that means. Step 2 here. Okay, step 2 says because it's affecting the y value, so what I'm going to do is multiply y value by a 2. Okay, so I would take any points, right? If I got 3 points, I'll take those 3 points, I'll subtract 2 from the x value, I get new points, right? Then I'm going to multiply the y value by 2 and get brand new points again. And then those brand new points can go, and I'll show you when we do it later on, okay? So that's how we kind of know. So let's talk about if I had, let's say a parabola, right? So if I have a parabola, right? And if I was to do a vertical stretch to it, okay, then it's gonna look something like this. Actually, I'll show it this way. So it's actually gonna go something like this, right? Where the parabola actually got narrower because you're stretching it. That way, okay? And then a vertical shrink, so that's why this is narrower. Try to get rid of all of these as much as I can. Where a vertical shrink is going to look something more like this, where I'm just trying to compress it. Okay, so that'd be a vertical shrink, so it becomes wider. So notice the vertical shrink says wider, and vertical stretch says narrower or skinnier. Okay, and then if we do it horizontally speaking, it's okay, I'll redraw it. So if I do it horizontally speaking, right? If I do a horizontal shrink, then same thing. Now I'm going to get something like this, right? Because what I'm doing is taking this and I'm shrinking it, right? However, if I did a horizontal stretch, then it will look something like this, right? Because what I'm doing is stretching it out that way. So it becomes wider. So notice how the horizontal stretch is wider, right? So for me, I like to think of narrower and wider because when A is greater than 1 or B is greater than 1, it's still going to be narrower. While if it's like 3/4 or 1/2, I know it's going to go wider. Same thing here, it's going to go wider. So that is what's going to be in common, so it's easier to see, okay? So that's how you would know. So let me get rid of those highlighters there. Boom and boom. Okay, so that's how you would know if it is a stretch or a shrink. So in this case, because it's a 2, okay, so 2 means it's going to go narrower, and it's affecting the y, so it's going to be vertical, so this has to be a vertical stretch. Anyway, and you confirm it right there, right? Because A is greater than 1, so it's going to be a vertical stretch. Okay. All right, so if we take the other one, which is g of x equals 1/2, okay, so g of x is equal to 1/2 square root of x minus 4, okay. Same thing, if I look at the 4, that tells me that that is the first thing I got to do, which means I'm going to shift right 4. Okay? Which means I'm going to add 4 to the x values. All right? And then the 1/2, which I put in blue, tells me to multiply the y values by 1/2. Okay, which tells me that's going to be a vertical because it's affecting again the y value, so it's going to affect it vertically, and since it's 1/2, it's going to make it wider, so vertically you'll have to be a vertical shrink. Okay, so I always picture those in my head as I'm going. Okay, so that should answer that first question. And if you go to the 5.2 notes, the very last example I put, you will see what I mean by taking a point and making these type of adjustments to them. Okay. All right. So this one right here, how do you know is not a parabola? So first of all, if you look at these parent functions, this is also in the 2.5 notes, is that x squared tells you it's a parabola. Okay, where if it's x cubed, is no longer a parabola, is actually a cubic function actually. Okay, so that's why it's not a parabola. All right. So now number 3, I didn't know which one you were talking about because this one would be this is lab work 4 number 10. So lab work 4 number 10. The way you would do this is, again, f composite g of x means f of g of x. Okay, which means I'm putting, so I know f of putting the g of x, 10 over x, into the f function. Into the f function. So this would be 10 over x plus 10. Okay, so 2 pieces here. I have 2 denominators. So it's because I gotta find the domain here. So I got 2 denominators. One is this denominator here, which tells me that x cannot equal to 0, because if it was 0, then 10 over 0 would be undefined. The second piece is going to be, let me see, let's highlight it in green. The second piece is this whole thing right here. This whole thing tells me that 10 over x plus 10 cannot be 0 either. This you can solve, okay? So I can bring the 10 over, so I got 10 over x equals negative 10. Multiply both sides by x, so I got 10 equals negative 10x. So x cannot equal to a negative 1, okay? So there is my 2 no-nos, right? So I can't have those 2, so that means my domain can be anything else except for 0 and negative 1. So that means I can go from negative infinity, ooh, that's awful. Let's try that again. From negative infinity to negative 1, union with negative 1 to 0, union with 0 to positive infinity, okay? Because the only thing I can't have is negative 1 and 0, all right? So it would be choice C, choice B, okay? All right, however, if I decided to use this number 10, which I believe this is lab work 5, so this is lab work 5, number 10, it says to draw the inverse. So to do the inverse, all you have to do, especially with graphs, is to switch the x and y. So what am I going to do? I'm going to zoom in. I'm going to look for some points here. So let's see here. Right here I have -3, 0. Let me see here. This looks good. This is 1, 2. And let's get one more point. I think this is a good point right here. This is 6, 1, 2, 3, right? Okay, so that's what I would actually do. I would say, okay, so there's my 3 points, -3, 0, and this is my f of x, right? No, it doesn't say. I would just call it f of x. -3, 0, 1, 2, and 6, 3. So my inverse, f -1 of x, which is my inverse, I would just switch to x and y. So my new point is 0, -3, 2, 1, and 3, 6. So if I plot that, 0, -3, 2, 1, and then I got 3, 6. So there's my 6, there's my 3, so right here. So that means my graph is going to look something like that. Okay? So if you look at that graph, it's also a reflection over the line y equals x. Okay? So the line y equals x, let's put it in blue. Okay? So that line, y equals x, is going to be basically this line here. Okay? So this is y equals x, and let's go ahead and highlight that into blue. Okay? So if I reflect it over that, that looks like it, right? Looks like I did reflect everything right over where it's supposed to be. Okay? So there's my points. All right? So that's how you would know if you have an inverse or not with a graph. All right. So now this one here, I want to bring over. This is, I believe, lab work 6. Since there's already so many questions anyways, I might as well answer this one too. So this is going to be lab work 6, number 10. So it wants to find the inverse. So to find the inverse, right, so I'm going to replace the f of x with y. Then I'm going to switch the x and y. Then I got to solve for y again. So if I'm going to square both sides, I'm going to have x squared is equal to y plus 5. Then I got y is equal to x squared minus 5, right? So my f -1 of x is going to equal to x squared minus 5. Okay, so that would be my answer there, which is A. So that's how you would find the inverse of a 1-to-1. Okay, so again, now let's talk about the domain. All right, so with the domain, the nice part about domain is that you're basically asking yourself, what can you not have, right? So I love this problem here, x over x minus 6, or the square root of x minus 6, I should say, all right? So this tells me two things, right? So number one, as a fraction, the bottom can't equal to 0. But at the same time, I also have a radical, or a square root, right? So I cannot take this, so under the radical, it can't be, so not negative, right? And so it can't be a negative in the radical, okay? So when I look at those two, well, the radical part says that whatever's inside has to be greater than or equal to 0, because I can take a square root of a 0. But the problem is that because of the fraction aspect of it, I actually have to take away the equal part. Because if it was equal to 0, I can take the square root of 0, right? If I take the square root of 0, it's a 0 in the denominator, so it's no good. So essentially, I got to solve for this part right here, so x is greater than 6. So now this tells me my domain is actually from 6 and beyond to infinity. So that would be my domain. Okay? Your other one is a little bit easier. So I have 5x over x squared minus 49. So you did this in intermediate algebra. So you did 5x over, you factored x minus 7, x plus 7, right? So again, that's the denominator. So that's, again, fraction, right? So the denominator can't be 0. So you say, okay, x minus 7 cannot be 0, and x plus 7 cannot be 0. So x cannot be 7, and x cannot be negative 7. But it can be anything else. So again, it will be, so my domain here would be from negative infinity to negative 7, from negative 7 to 7, and then from 7 to infinity. All right, hold on just a second. All right, the only thing I'm missing here is my so-called unions. There we go, perfect. So I need to just put some unions in there, and then I'm good to go. All right, and then your last question, which is going to include all of this. So your last question talks about how does the horizontal line test. So here's the definition of horizontal line test. So I figured if I wrote it out. So in other words, if it passes the horizontal line test, it means that the inverse is a function. So the inverse would pass the vertical line test. That's all it really means. All right? I hope this helps. Talk to you later. See you. Bye.